So welcome to today's Oracle Machine Learning Office Hours feature highlight session. Our topic today is batch scoring using OML Services on Autonomous Database with Miles Novotny and Sherry LaMonica. I'm your host, Mark Hornick. In this session, Miles will introduce us to OML Services with a focus on batch scoring, and Sherry will take us through a demonstration of the batch scoring REST interface. Now, you're likely already familiar with scoring using in-database models from SQL, and this uses the prediction operators. Well, with OML Services, we support model deployment and management and enable real-time response for singleton and small batch scoring. So today, you'll hear about how you can also use the same OML REST API for large batch scoring as we have for singleton and small batch. And this makes it easier for application developers to cover a wide range of use cases from a common interface. Now, before we begin, let's have a quick poll. Which features of OML Services have you used? Perhaps it's managing, deploying in-database models or ONNX format models. Maybe you used it for data monitoring or model monitoring. Perhaps just singleton and small batch scoring, which was its original main purpose. So we have 40% saying they've managed deploying in-database models. Few have looked at also data monitoring and model monitoring, and about 20% for singleton and small batch scoring. About 50% now saying they're managing deploying their in-database models there. All right, so thank you for that response. And let's go to our second question. How important do you consider asynchronous large batch scoring for application developers? Would you say that it's very important, somewhat important, not important, or you don't have an opinion on this topic yet? So the results are coming in. I think we have easily about 40% saying very important or important, and a large number of people, 50%, don't have an opinion yet. So hopefully we will give you some insights as to why this is an important feature going forward. All right, well, thank you for your feedback on that question. And with that, I will turn it over to Miles and Sherry.
All right, thank you for the introduction, Mark. Miles Novotny here, and I'm happy to be here with Sherry LaMonica today to talk about the new batch scoring feature for OML Services. So let's go ahead and look at our agenda for today. I'm going to start by giving a general overview of OML Services, then focus in talking about the new batch scoring feature. Then I'll walk us through a workflow of how you'd go about creating these requests for batch scoring. Then I'll hand it over to Sherry. She'll give us a demonstration, and we'll finish up with some Q&A. Let's start with our OML Services overview. So OML Services extend the functionality of Oracle Machine Learning with things such as model deployment, management, and monitoring services as well. This is something that is available on Oracle Autonomous Database Shared, and it really enables some key functionalities for an effective enterprise MLOps strategy. One of them being that OML Services is optimized for fast scoring performance for your streaming, real-time, and batch applications. We also have built-in cognitive text services for a couple different languages there. And a very important thing to note with OML Services is that you only pay for actual scoring compute when you score your on the service. There's no hidden fees that come along with using the service. You're just paying for the scoring compute for it. So that is very important to note. So let's dive into some different aspects of OML Services. First, with model deployment on OML Services. So you can deploy your native and database Oracle Machine Learning models, but on top of that, you can also deploy third-party models that are stored in an ONNX format. And these models can be of a classification, regression, clustering, or feature extraction type to be deployed on OML Services. And then once you have deployed them, you can score them either synchronously with single and small batches of data, or asynchronously with your large batches, which is that new feature that we're going to dive more into later in this presentation. Additionally, you also have cognitive image functionality. So you can employ an ONNX format model that scores using images, for example. So that's a great extension of the functionality there for the use cases available. So how about managing models with OML Services? So you can store and manage those in-database and those ONNX format models, as well as their metadata, using the REST endpoints of OML Services. You can also retrieve these models back to your database if you'd like to interact with them through the SQL, R, or Python APIs of Oracle Machine Learning. Again, you can create those scoring endpoints, score with singleton, small batch, or large batches. You can also version your models, compare them, organize your models within their namespaces, pretty much all the operations you need to do to organize your set of models that you're working with. And then when it comes to importing those ONNX formatted models, they could be in popular third-party packages that you like, such as TensorFlow, PyTorch, scikit-learn, whatever it is that you'd like to use there. I mentioned that OML Services has monitoring, but what exactly does that look like? So with OML Services, we have data monitoring and model monitoring. This is a fairly new feature to OML Services. It was actually the topic of one of our recent office hours. So model monitoring is all about detecting model drift, which is essentially just degradation in the prediction quality of a model in deployment. So, it's clear that organizations want to have the most accurate model being used and deployed at all times. So model monitoring is really important for this. You can look at the degradation of a model, understand how its prediction quality is worsening over time, and make sure that you have a model ready to replace that model once it degrades past an acceptable point. Similar to model monitoring, we have data monitoring. And data monitoring is about, understanding data drift, significant changes in statistical properties and profile of your data. Now, this goes hand in hand with model monitoring because data drift is a really common cause of model drift. It makes sense that changes in the underlying data being scored would cause the quality of the model to drift. So once you see that your model quality is drifting, it's good to look at your data monitoring results as well to understand how changes in the data are changing the model quality. Data monitoring is also useful outside of an ML context. For example, maintaining data quality, just understanding changes in important data sets in your organization. So these capabilities are really important for an effective enterprise MLOps strategy, making sure you have the best models in production and that you understand what is happening with your data over time. Let's get to the main point here of today's session, being the new batch scoring feature of OML Services. So what is batch scoring and why is it important? Batch scoring is just the scoring of multiple data records asynchronously. You can think of, a group of all of your customers, employees, or information about equipment, and you're generally accessing this data through a database table or view. This is different from your singleton or small batch scoring. With that type, you would generally have the data to be scored in the payload with your REST request. So you'd include, the record or couple records that you want scored. You send it in your REST request, and you get the scoring results in the response directly, synchronously right away. Your asynchronous batch scoring is different. You'll see we're just going to reference a database table. It'll score all the data in that table and store the output in a different database table. So it works a little differently. The asynchronous nature is also useful because you can schedule it to run on a schedule. If you'd like to do the scoring, weekly, monthly, that's something you can do. And when we start to talk about some of the use cases for this asynchronous scoring, it can include lead generation, looking for churn, demand forecasting, supply chain optimization, just any situation where you want to score a large amount of data at once. If you're looking for churn in your customers, you're not going to look at a single customer for that. You want to understand churn in your entire organization. You're going to score a lot of customer data at once. There are also use cases where it makes sense to just use singleton scoring. You can think of fraud detection, for example, scoring individual transactions as they happen to see if they're fraudulent or not. So it's important for an enterprise to have effective batch scoring and singleton scoring options. So it's really important that OML Services has this functionality to make sure that your MLOps strategy can accommodate all these use cases. And again, we're talking about support for regression, classification, clustering, and feature extraction models here. I quickly want to note, when we're talking about this new feature of OML Services, we're talking about deploying these models to be accessed through a REST API, very useful for access from your applications, for example. But these models are essentially automatically deployed in the database at creation and able to be used for batch scoring, for singleton scoring. So this is something that you've always been able to do. You can just now access batch scoring through the REST API of OML Services. We have an example here on the left. We have our classification model being created to predict customer acceptance of this affinity card program. And after we run this code on the left and create the model, right away, we can do scoring with it here. So we're trying to understand customers that are greater than 50% likely to be affinity card responders. So, just to understand that batch scoring is something that has been available with Oracle Machine Learning. We're just now making it easier for app developers to access this functionality through REST APIs with OML services. We're going to walk through the workflow here of how you'd go about creating this batch scoring request. First, we can take a look at the full breadth of possibilities with this API for OML services. We have the functionalities broken into some different areas here. Looking left to right, you have your admin requests, which is to get a token using your ADB username and password to then access and work with OML services. You use your OML login to get this token, and then that token authenticates your request to OML services. You have your repository requests, which include storing models, updating your model namespaces, deployment requests for creating endpoints, and scoring those models on those endpoints. With your asynchronous jobs, this is where your batch scoring happens. You can create asynchronous jobs for batch scoring, as well as model and data monitoring, which we just talked about. And then you have your cognitive text functionalities. So let's go ahead and look at the workflow to create a batch scoring request. So that workflow starts with getting your access token to actually authenticate your request to OML services. So to do that, first you send a request to this OML users path, and this request includes your username and password, and your database will return you a token with which to authenticate your request to OML services. Your requests to OML services go to this OML mod path, and using that token, you can send your payload. But how exactly do we get the URL on which this path is included? So we can find that URL in the database actions section of our autonomous database. Click database actions, scroll down to the bottom, and we can see a number of useful URLs. This one here is the URL used to obtain your token. And then down here, we can see the URL that you'd use to then interact with OML services after you have that token. You can see that these URLs are actually exactly the same, except for this OML users path and OML mod path that is appended at the end. We can look at exactly what this URL looks like. It's made up of 4 things, being your tenancy ID, and then your database name, which would be OMLDB in this example, your data center region. So this one's in San Jose, for example. And then they all end with this root domain, oraclecloudapps.com. Once you get your URL from database actions, we can send that request to get a token. We can see this is to that OML users path, to this token path to request our token. We can see in our payload, we have our username and password for our OML user. And using this information, we'll be returned a token. We can store that token as a variable and then use it to send requests to OML services. We got our token, and now we can submit our batch scoring request. This request is cut in 2 here. It's quite a long request. So this is the top half of it. The bottom half is on the next slide. Looking at this, we can see we're sending this to OML services. So this is the OML mod path to V1 jobs to submit a job with a post request here. We can see that we have a variable here storing the token value that we got in our last request to authenticate this request. And now we have the payload of our job request, starting with the job schedule, which just defines the interval over which this job is going to happen and how often it's going to happen over this interval. So we can see this job is happening from April 10 to April 15th, and it's going to run daily. So once a day over this time interval. We can also set the max number of runs. Here it's 15. So it only happened 5 times according to the schedule. You can also manually invoke a job outside of its defined schedule. So this max runs means that you cannot have it run more than 15 times between manual invocations and the scheduled invocations. We define when this job is going to happen, and then we define what's actually going to happen with this job with our job properties section. So we can give our job a name, and then we define the job type. It's going to be batch scoring, obviously. Our other options here would be model monitoring and data monitoring. As I mentioned, those are your other asynchronous job types. But we're doing batch scoring here. We need to define the model ID of the model that's going to be doing the scoring. And then we have the input and output data. So the input data references an existing table in our database. And we're going to score all of the records in the database using this model that we reference with the ID. Then this output data is the name of a table that will be created and populated with the results from that prediction. Additionally, we can specify supplemental columns we'd like in that output data table, our database service level, and our top end predictions and top end details. This tells us the number of top predictions we want returned for each row. So say we have a classification case and there's 5 possible values that this classification can be. Top N will return the top 2 predictions given by the model. So we could specify, how many predictions we want for each row, and then also how many of those predictions we would like the details returned for. So we want 2 predictions returned and the details for both of those predictions. And then we set recompute to true here. So when recompute is set to true, every time this job runs, it'll rerun the entire input data table and do the calculations on all of them. If we set recompute to false, it'll only compute on new records every time. So say we run it for 1 month and it computes the entire table. And then over the ensuing month, we get 100 new records. When it runs again at the end of the next month, if recompute is set to false, then it's only going to score those 100 new records. If it's set to true, it scores the 100 new ones as well as all existing records. So once you have created your request, you can see that it was created properly by listing all available jobs. This is also a request to that OML mod jobs endpoint, but it's a GET request this time. It'll also show us all existing jobs. It'll show us the job ID as well. So we can identify our job, grab that job ID, and using it, we can look at the in-depth details for our individual job by appending the job ID to the end of the path. We can see settings like the ones we defined in the job request, and we can see like when the request was created. Also very useful is that it tells you information about the last job run. So if this job ran once already, it'll tell us if that run was successful. If there was an error, it'll give us an error message helping us understand what went wrong with it. So there's a lot of useful information on this details page. So I've explained enough about how this happens. I'm going to pass this over to Sherry and she's going to show you it now.
Okay, thank you, Miles. So you are looking at Oracle Machine Learning Notebooks, and this is a Zeppelin-based notebook interface, and it's readily available when you provision your autonomous database. And we're going to walk through a batch scoring workflow for our classification model. And you'll see some curl commands in here, and you can't actually run these in the notebook. They run in a terminal window on your Linux or Mac machine, or even the OCI Cloud Shell, but they won't run directly here. It's for illustrative purposes only. I will show you how to run them using a Postman REST client. Okay, so as Miles mentioned, the first thing is that you send a post request to get a token when you include your OML username and password and your service URL in that payload, and then you get back a token, and that gives you access to all of the REST endpoints for OML, including the batch scoring endpoints. Next, we have to get our model ID. And in this scenario, our model has already been deployed through the AutoML UI or through a REST client using OML Services REST endpoints. You'll need the model ID for the deployed model that you want to use for scoring, and you can find the model ID by sending a GET request to that deployment endpoint with the model URI, which was specified when the model was deployed by the user. And then we're ready to submit the batch scoring job. So to create the job, we'll specify the job name, the job type, which is model scoring, the schedule frequency, a maximum number of runs within the schedule, the model ID, the input data table name, and an output table name to store the scoring results. You also include supplemental columns, and this is can be unique identifiers like case ID for your records to identify the resulting scores. And we're asking for the top 2 predictions with details contributing to those predictions using top N. And by doing this, you're going to see that you get back not only those probabilities, but you get back the prediction details, and the details tell you the columns that were determined to be the most important for that specific record or customer. We're also setting the database service level to medium. Low is the default, but medium offers some parallelism. There's also a high service level that enables the most parallelism, but limits the number of concurrent jobs. Medium enables some parallelism, but allows a greater concurrency for the job processing. So once the job is submitted, this is the return value. So you get a job ID and returned, and you'll use that job ID to interact with the job, like viewing its details or updating the job or performing an action on the job, which I'll show you shortly. If we wanted to look at the job details, we send this GET request to this jobs endpoint with the job ID. And this is going to show us all of the parameters that we set in the job request, but it also shows the defaults for the optional parameters. There are a number of optional parameters as well. You can check that out in the documentation, and you can also see them here with their defaults. And it also gives information if the job is actually run. So in this case, the job is enabled to run, which is the default, and it's scheduled to run, but the run count down here indicates that it hasn't run yet. Okay, so once the job has run, we can run a SQL query to view the table containing the batch scoring results. So the output table name, as you can see here, has both the job ID and the output data that was defined when the job was submitted. So here we have the prediction probability, possible outcomes of 0 and 1, and their corresponding probability. So we also have the prediction details, which provides the predictors that most contribute to the result and their corresponding weight. So for this customer in the first row, probability of 0 is in OML probability 1. And probability of 1 is in the column OML probability 2. Household size is the most has the most impact on this particular prediction, and the second most impactful is occupation. And then the weights, the prediction weights, are in the OML detail weight 1 and OML detail weight 2 columns. So we can also perform actions, update, and delete batch scoring jobs. OML Services is interacting with the DBMS scheduler to run these jobs. And so the actions are going to be the same as the DBMS scheduler. So we can disable a job if it's not enabled, which enabled is the default, but you can submit a job disabled if you want to. And we can run a job just to test it outside of its schedule, and we can also stop a running job if we want to. So to do that, I'm just going to send a post request to this action endpoint with the job ID and then specify the action in the payload. In this case, I'm disabling a job. So I don't want that one to run anymore on its schedule, but I can enable it at a later date. I can also update a batch scoring job, parts of the schedule. So you can specify a different start and end date, a different frequency, repeat interval, and the maximum number of runs can be updated as well. Here you can see in the payload, I'm passing a new job schedule for start date, end date. Instead of daily, I'm going to run this job hourly, and I want 20 maximum runs. And so again, this is what this would look like if you were running it from a Linux terminal. I will show you how to run these through Postman REST client as well. And finally, to delete a batch scoring job, you just delete your job ID, you send a delete request, and your job will be deleted. This notebook will be available after the session if you want to reproduce this, including we have a download for the serialized model that we used for this example. Okay, so now let me show you what this looks like in Postman. This is Postman, and it is easy to use. It's a free download, and it's a client for REST, and it's easy to install as well. So you just download it, and then you can start creating these REST requests that can be saved in collections, which is like a project. And so here I have my OML Services batch scoring collection for office hours. And the way that this works is that you have an environment where you include your OML service URL and your OML username and password. And in this case, I'm saving everything to variables so that we can run it easily. You can hover here to see the value for your variable at any given time. The variables are denoted with these double curly brackets. Anyway, the first thing that I want to do is to get a token. So I just hit send, and I will get a token back that I can use for the remainder of my REST requests. So here's the token, expires in an hour. If I want to take a look at the OML Services Swagger file, the documentation, you send a GET request to the OML mod v1 API. And I have all of the different methods, everything that you would need to run a REST request is listed in here. And we also have this in the online documentation as well. So earlier I had mentioned that my model was already deployed. So there are two ways to do this. You can do this with a click in the AutoML UI, but you can also do this through OML Services REST. And here there's two steps. I first need to store the model in the model OML Services model repository. And in my request body, I'm passing this model file. This is the serialized model that I created in my database. And I saved it locally, and I can navigate to that here. And that's the model data. That's the model file. I'm giving the model a name, which is NN-mod. The model type is OML, because it's an in-database model. A version shared. Shared indicates that another user can deploy the model in your database. If you want to share the model so that another user can create their own deployment, that's fine. And then I create a scoring endpoint. And here I'm providing the model ID and the model URI that was specified no, you're specifying it right now, actually. And then I'm sending a post request to the deployment endpoint, and then my model is deployed and I can start scoring. So here I can list the model. Here, there's a filter here for model names. So if I want to look at some of the details for this model, I can send a GET request to the models endpoint, and I can see certain things like the model version, the model type, who it was created by, the model ID, another way to get the model ID, the model name, and when it was stored, and if it's shared. This is my batch scoring request. So if you saw this in Miles' slides and in the notebook with the curl, but if you want to use it, run this using Postman, you can just send a post request to the jobs endpoint and put all of the parameters in the job schedule and job properties here. And if you notice, I don't have a job start or end date because I'm just going to run this instantaneously. And then I get the created response back, HTTP response, which means that the job was created along with the job ID. And now I can look at the job details by passing the job ID to the jobs endpoint. You can see the frequency, the job type, which is model scoring. Miles mentioned there's also monitoring job types. And then if I want the job to be disabled upon submission, the default is false. And then our top end and top end details, which is optional. And recompute is set to true to replace the output table every time the job is run. I can update my batch scoring job. Here I am going to run it monthly with maximum of 2 runs. And I can also perform an action on a batch scoring job. In this case, I just want to run it outside of its schedule. There's no content, but what I could do is go back and query that output table to see the results. If I want to see all of the jobs that I've submitted, I can filter on the job type if I'd like, in this case, model scoring, and I can see all of the model scoring jobs that I have along with their job ID and other details. And then finally, to delete a batch scoring job, I just need to pass the job ID to the jobs endpoint with delete, and this will delete the batch scoring job. There's no return value, but the 204 indicates that the job was deleted. Okay, that's all I wanted to show you for today. Back to you, Miles.
All right, thank you, Sherry. We have a few resources for you, including if you'd like to learn more about this batch scoring feature, Mark wrote a blog about it. Also, this OML GitHub repository has the example notebooks and Postman collections that Sherry referenced in her demo, if you'd like to download those and use them yourself.
Okay, and with that, I think we are all set. So thank you very much, Sherry and Miles. Until next time, enjoy using Oracle Machine Learning Services.